Hi everyone. We are looking at the impulse momentum principle. Impulse and the momentum, how these two things are related. We've already done something on momentum. We've solved a lot of problems on momentum, but we haven't yet on impulse. So, what is the impulse of a force, of a constant force applied to a body? We want to define what impulse in terms of physics and maths. What's the impulse of a constant force applied to our body? Well, it's simply the force that is being applied to a body or an object multiplied by the time over the period in which that force is applied. That's the impulse. In other words, the impulse I is equals to F times time. F, that is the force applied on the body in newtons, the unit there is newtons, multiplied by the time, that is the period in which that force is being applied on the body, and that time is expressed in seconds, units, seconds. This is the impulse. Force times time, newtons times time, newtons times second. Yeah, let me put newtons second. This is the unit. Now, what about momentum? What about momentum? We also know that when a combination of forces acts on a body, we can call those forces resultant force, because we can be able to resolve them maybe on the x and positive on the horizontal and vertical axis. We'll be able to resolve those forces along the horizontal and vertical axis, and then we can be able to combine those forces and call them a resultant force. That's what we mean. If you, for example, if you have a body like this and you have a force going that direction, another force going to towards this direction, you have 20 newtons here, for example, and you have 15 newtons here. So you have two forces acting in opposite directions. So for you to be able to find the resultant force, this is bigger than this, so the particle must be going towards that way. So it's going to be 20 minus 10 newtons. This is 20 minus 15, sorry, newtons. So your resultant force, therefore, is 5 newtons. This is your resultant force. You have this set of forces acting on this body here. Your resultant force is this. So when you talk of a resultant force, we mean a combination of forces being resolved into their respective components, x or y components. Yeah? So we know that when a resultant force acts on the body, it will always cause that body to accelerate, just like what you have done here. If you have this particle, 15 newtons, the particle is drawn by 15 newtons towards that direction, and 20 newtons is being drawn towards this direction. The particle will definitely accelerate towards this direction on the positive xy direction, on the positive x direction, because the force here is greater than that one. So when forces are applied to a body and they cause that body to accelerate, that is the second law of Newton. Second law of Newton. And what does it say? It says F is equals to mass times acceleration. Second law of Newton's. So we now want to find, we see force here, impulse equals to force times time, force equals to mass times acceleration. It means there is something common to these two functions. Impulse, you have force, force, you have mass times acceleration. This is Newton's second law of motion, don't forget. We have acceleration here. And then, we need to do something. Acceleration. You know that according to the laws of motion, when the acceleration is constant, you have v, final velocity, equals the initial velocity plus the acceleration of that body times the time. Right? What are we looking for here? We want to get rid of this I. The I from here, we don't want it. That's what we are trying to do. We are trying to draw a relationship between force and impulse. So here it means, here you will have v minus u, final velocity minus initial velocity, is equals to acceleration times time. We are just doing change of subjects here. So now we want I. So what do? We divide this by t, we also divide this by t. So now you will have v minus u divided by t must be equals to a t divided by t. They are all the same. We haven't done anything. We just divide this side by t and divide this side by t as well, so that the equation remains unchanged. So now, if we cancel t here, they will go. We'll only have the acceleration here. And then we'll have v minus u over t equals acceleration. Right? So, now, if that is the case, let me find space here. If that is the case, don't forget, we already stated that I, impulse, is force times time. And now, for this one here, we now have F is equals to the mass times acceleration. But we found out acceleration to be v minus u all over t. Correct? Yes, acceleration of final velocity minus initial velocity over the time. So, if that is the case, now we can just cross multiply this. We come over here. So we now have Ft equals mass into v minus u. Let me say this is equation 1 and this is now equation 2. And what is Ft? What do we have for Ft? Ft is impulse. Ft is impulse. Ft is impulse. So that means the impulse now is equals to m, we open this bracket, mv minus mu, equation 3. So impulse is equals to the mass times velocity minus mass times final velocity minus mass times initial velocity. And what is this? This is momentum. You know this formula. You know this is momentum. So we now have a relationship between the impulse and momentum, which we call as the impulse momentum principle. This is the impulse, and this is the momentum of a particle. It's the mass times the final velocity minus mass times initial velocity. Right? So establish this formula, which is very important. This one here. We've established it. So now let's solve problems. Problem number 1. Problem number 1 says that a particle is acted upon by a constant force of 7 newtons for 15 seconds. Find the magnitude of the impulse given to the particle. Number one. So, we have a particle is acted upon by a constant force. The force is 7 newtons. For 15 seconds, time is 15 seconds. You are asked to find the magnitude of the impulse. So what is impulse? You know impulse is equals to F times T. So we have F here, which is 7 newtons, times T, which is 15 seconds. So if you multiply this, 5 times 35, carry 5, 5 times, carry 3, 7, 105 newtons seconds. This is your final answer for number one. Straightforward. Thank you for watching. Bye-bye.